Hello everyone. So today we're going to talk about expected value, variance, and standard deviation. And I've had several people coming in with this to me already, and what I've noticed is a lot of people know what they're doing, but the issue is plugging in stuff in the calculator. And this is not the most trivial thing to do, even if you have like an TI-83. And I personally think that doing this in Google Sheets or Excel is probably a much easier thing to do. So let me show you what I mean. So let's talk about the mean, right? Or expected value. So over here, I have a lovely data set. I have exactly 7 points, and they are all kind of, some of them could be a few points from each other and so on, right? And I want to find the average, the mean. You all know what a mean is really well by now, because your grades in my course, for every single assignment, it's the average or the expected value or the mean of all of your attempts. So let's say you have a 69 on the first attempt, a 72 on the second attempt, and 100 on the third attempt, and you're wondering why your final grade is an 80-something. Well, that's because you add those three up and divide them by 3, right? So this is what the mean or expected value, as I prefer to call it, means. Okay, so how do I calculate it? In Excel, it's super easy. You quickly enter your data set, and then you do this. The equal sign, and then you say, well, it's the sum, right? So you just type in sum, and you select all of the values that you want to add, and close the parenthesis. If I were to hit an enter right now, I would get the sum of all of these data points. But I don't want the sum, I want the average. So the average is the sum divided by the number of the data points, like our formula over here says. So I'm going to go ahead and divide it by 7. And here it is. It's my expected value or mean. Okay. So very, very easy, right? So next, let's talk about how to find variance. And here's the formula for my variance. It's right here. And you should be asking yourself, well, this looks very complicated, and just like, what does it even mean? Well, let me explain to you where the variance comes from, right? So we wanted to find how far each data point is from the mean. Because you can have situations where you have, for example, 100 students taking a test, and somebody got 100 and somebody got a 50 and somebody got a 75, and you want to know, are they all really closely clustered around, say, 75? So you have mostly C students, or maybe you have a whole bunch of A students and a whole bunch of F students, right? And then you have a real issue. So the measure, the variance and the standard deviation, they will both tell you how far away most people are from the mean, okay? So maybe some are failing and some are acing, or maybe everyone is close together. And that is what it will tell you, right? If they're all close together, then your standard deviation and variance is going to be fairly small. If you have a bunch of people failing and a bunch of people acing, you're going to have a very large variance in standard deviation. So before we do this, right, well, let's try and figure out how we could possibly do this, right? So the very first thing that I would think of when I'm thinking about this, right, what's the difference between the data points? Well, what if I do this, right? Hold on, that other image. Okay, there you go. Okay, so what if I do this? What if I calculate every single data point, how far away it is from the mean? That should be really easy, right? It's just the data point minus the mean, and then I will get some kind of distance, right? Should be pretty easy. And I can easily do that in Excel. So I'm just going to put an equal sign, and then I'm going to have my data point minus my mean, like that. And bam, I have the answer. Okay, well, what if I want to do it for all of them? if I just copy and paste this, I will get my data points again, because what it will do every single row. This cell, this column minus this column. Since I want them all to minus this number, I just need to add some dollar signs to it. If I add the dollar signs, it holds this cell constant and doesn't move down this column. So when I copy and paste, again, I Control V and then Control C and Control V. And now every single one is, say, A6 minus B3 and so on. So all of them are minus that cell. You will notice I have a problem, right? If I will want to take the average of these numbers, like half of them are negative. Yikes, okay? Because negative and positive numbers have this unfortunate tendency, they cancel out, right? So my sum, if I have a whole bunch of negative numbers and a whole bunch of positive numbers, is actually not going to give me a meaningful answer, because I'm trying to figure out how far away. And the thing is, when I do how far away, right, it doesn't matter if I get a negative or a positive number. I just need the distance, right? So ideally, I would take the absolute value, or I would square this to get everything positive. So this is why in variance, it's every single point squared. It's to avoid this whole situation where we have minuses, because those minuses will cancel out when we add them up. All right. So if we need this squared, I need to replace this. So I'm going to go ahead and replace this. And didn't replace it. So it's the same thing, right? I've got each data point minus the expected value, or the mean, but now I want it squared. Very easy. I look back into this formula where I had this cell minus this cell, and all I do is put them in the parentheses and square them like that. Little hat and then 2. So now it's this thing squared, and I'm going to Control C and then select all of these and Control V. And now I have all of the distances squared, and they're all positive. So now let's look at my variance with a fresh eye, okay? This is just the sum of all distances squared divided by n. In other words, it's the average distance. So once again, we're calculating the average. So that's very simple, right? This is just equal sign, sum, all of these, and I have exactly 7 data points, so divided by 7, and this is my variance. Now, the problem with this is I squared all of my distances, right? So it doesn't give me a meaningful distance anymore. It gives me a square of the distance. So how can I find a distance that is actually like real? Well, I take the square root, which is what standard deviation is. This is literally just square root of variance. So, super easy. I'm just going to do equal sign, square root of this cell, which is my variance, and bam, I have my standard deviation.